Today we're going to learn how to solve right triangles. And when you see the directions say solve a right triangle, that means that you're going to find the missing lengths of its sides and find all the measurements of its angles. And you do that by using one of the trig functions like we've been doing. So I'm just going to draw this triangle. And the angles are always labeled with uppercase letters, and then the side lengths they use the lowercase letters. And let's say this angle A is 34.5 degrees. Okay, first thing you need to remember that all the angles of a triangle add up to 180 degrees. And if you notice, we already have two angles. So we have the 90 degrees, which is angle C, and 34.5 degrees, which is angle A. So that gives us 124.5 degrees. We know they all have to add up to 180. So what I'm going to do is subtract so I can find my missing angle, which will be angle B. And that'll give me 55.5 degrees. So that's angle B. And now, all we have to do is find all the missing side lengths. Okay, and then this is where you can use any of your trig functions. And I'll just put them back, the ratios. And if you notice, we have to find side A and side C. So, since I have the angle across from side A and the side length, I can do opposite over adjacent. So I would do tangent 34.5 degrees equals opposite, which is side A, over adjacent. And then I would just solve for A. So that cancels. I'm going to multiply this side by 10.5. So A would equal approximately 7.2. And then to find C, and I always use the angle that they give me just in case I mess up with finding the one that was missing. To find C, this would be, I can use cosine, which is adjacent over hypotenuse, because I'm still looking at this angle A. So cosine 34.5 degrees equals 10.5 over C. So I would solve for C, multiplying C by both sides, and then I would get C times cosine equals 10.5. And then I would divide this by both sides. And then I'm going to get C equals, and very important, make sure your calculator is in degree mode. And that'll be approximately 12.7. So now I have solved this triangle. Solving a triangle, remember, means you find all the angles. So you have all three angles, all three sides. And that's how you solve the triangle. Okay, we're going to learn about a term called bearings. And a bearing is used to specify the location of one point relative to another. And in navigation and surveying, people that are using navigation and survey use this term. And so how it works is you have, I'm going to use a different color. You have your north, east, south, and west. And so you have the north-south line, which is vertical, and the east-west line, which is horizontal. And they all form right angles. And right here in the middle, I'm going to use this as O. And so when you are describing a bearing, it has three parts. It has a letter. So you start off with either north or south. And then the measure of the acute angle. And then another letter, which represents your east or west direction. So those are the three parts to your bearing. And this is an example. So if you had something like this, let me erase this so I can write it neater. Okay, so it'll look something like this. And here's point A. And this will be 20 degrees. And they'll say, for example, okay, for example 1, they want the bearing from O to B. So we look right here at O. So from O to B, we're going to describe this line. So we need the acute angle between the ray OB and the north-south line, which is 40 degrees. They've already given us that. So remember, the way that you describe it is three parts. So first you give the direction whether or not you're closer to north or south. And so if you notice, it's closer to north. So you would say north, and the acute angle is 40 degrees. And then we're going towards the west. So this is how it'll look. So basically you are describing the location going from north to west is 40 degrees, but you write it like this. And then to go from O to A, you need the acute angle between the ray OA and the north-south line through O. And if you notice, the given angle is 20 degrees. That's coming from the south line. So if we want to go from the north, we're going this direction. And since the whole thing has to make a 90-degree angle, you just do 90 degrees minus 20 degrees, which gives us 70. So when we describe this, we say north, 70 degrees east. And that's how you write that. Let's try two more. I've added two on the bottom. So let's look at the bearing from O to D. So O to D would be from here to here, because you always start with this north-south line. So now we are coming from the south, and it's already given to us that is 25 degrees, and we're going towards the east. Okay? And then example 4 says the bearing from O to C. Okay, so now we have to start at the south line, and we need this angle right here. Well, if you notice, it's given 75 degrees. So what you do is you do 90 degrees minus 75 degrees, and that'll leave us with 15 degrees. So when we describe O to C, you're going to say south 15 degrees, and we're going towards the west. And so that's how you describe the bearing. So remember the three parts. You have to give the north or south direction, the acute angle, and then whether it's going towards the east or the west. And that's it.